This is the Amp Hour Podcast. Released September 26th, 2021. Episode 559. Occam's Engineering Razor.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
2 weeks in a row.
Yeah.
Yeah.
Well, that's, we got things to say, possibly.
Do we? All right. Well, I can
Electronics and things.
Well,
Yeah.
I can start off. As
Okay.
usual. You
Bring
have
it,
no
bring it.
idea. I'm going to say this. It's,
Yeah.
it just popped in my head.
Okay.
Have you ever had? I'm sure you have. It's kind of a rhetorical question. It happens to all of us. Have you ever had one of those moments where, well, it's not a moment. It's a it's a whole saga of where your engineering brain kicked in at you've got some problem, right? Something's gone wrong, and your engineering brain kicks in and just thinks of all of the possible things it could possibly be, and you go and investigate all of those, and it turns out to be the simplest, easiest solution because your
Occam's
brain,
razor with
kind of
anti-Occam's razor.
Yes, the engineering Occam's razor. Yes, the engineering razor. Obviously you've had that, right? I mean,
Yes.
that goes without
100%.
saying.
Yeah.
Yeah.
It's like the curse of knowledge type of thing. Where you've seen too
curse
much.
of knowledge. Yes. You know too much. It's
So what happened? Obviously, you have a story here.
Yes, I have a story with that. That's probably I'm going to go edit a video after this showing it, but maybe it'll be linked in by the time we do this. But yeah, it's my home solar system.
I'm looking at the tweets about it.
Yeah. Yep. I recently, so you probably know what the answer is. I recently installed a new 5 kilowatt system, right? But that supplemented my existing 3 kilowatt system. So what I did is I moved my existing 3 kilowatt system from the more ideal roof where we wanted to put the bigger one, and we put it on the other side of the roof, which was less ideal. In fact, it's fairly poor roof angle to put it on, but it's better than nothing, right? What am I going to do? Sell it? Scrap it? No, I might as well just move it, right?
Lean it up in the backyard against the fence or something.
Yeah, no, exactly, right? So I thought, I'll still get, I might get half the energy out of it that I used to because it's on the other side of the roof, but who cares, right? It's already paid for itself. It's free. Might as well move it, right? So I moved it, and then everything looked to be going fine, but then just like a week ago or something, I looked at some perfect days which we've been having recently, right? And if you've ever seen like the solar curve on a perfect cloudless day, it's just this smooth.
Yeah, you have a video of it that we'll share on your Twitter account.
Right. And, it'll have a beautiful curve. And then I noticed that it had all these it had these dips in it and stuff. And I thought, that was just like a cloudy day. The cloud came over. But then I was like comparing data with my old and new system, and I noticed that my new system showed a perfect curve for that same day. And my old system, which I've moved, didn't. It showed this big, wiggles in them, as I call them, right? These big dips and everything. And so I started looking into the data, and sure enough, every perfect day which showed up on my new system, so there were no clouds at all in the sky, I should have got a perfect curve on my other one, and I didn't, right? So there's something weird going on with my 3 kilowatt system that I moved. And then...
Right. And you start diving. So to take it
So
back
I
to the
start
Occam's razor
diving
thing, you start thinking like, well, it could be how the internals of the inverter are or whatever, right? And all these other things.
It could be the inverter, but the inverter wasn't okay. So we can go through all the different scenarios, right? We can go through, the troubleshooting, right? Obviously, okay, let's go for the most obscure, complex one. Let's go. These guys on, these contractors on the roof were physically throwing around these panels, moving them and stuff like that. And
got it.
there could be.
I should measure
damage.
the like that thing that Martin did where he showed like the cracks in solar panels.
Yes,
I need to go and measure
the micro
every
cracks
solar
and
panel.
things like that. Yeah, has these micro cracks and things. So I thought, look, there could be something wrong. One of the panels could be damaged, and because they're all in series, right? It's a big series string of 12 panels. If one of them goes bad, it will get bypassed and take down the whole, it can drop your whole system, right?
Yeah, right.
And so it could be that, or it could be, a dodgy connection or something that's, heating up some sort of, or it could be, thermal issues. Everyone, so I was putting all these theories on Twitter and everything, and everyone's coming up with, oh, it's got to be your inverter, or it's, so it's thermal, it's, this
Right. Well,
and that,
nothing's
it's damaged.
more useful than having people suggest things on the internet too,
on Twitter,
without much context.
That's why I put it on there, because it's just I just love to give people bait to then just kind of just throw wild theories out there. Everyone said it's the inverter getting hot. Post your temperature logs of your inverter. It's well, the inverter hasn't moved. It's in the same shaded spot it's been for the last 7-8 years. So it's not that. And mains voltage. 8 out of 10 engineers said it was mains voltage. Right? It was your mains voltage is getting too high because you've installed a new system on there in parallel. It's causing the main voltage to boost up, and it's causing shutdown of the inverter, like temporary, momentary shutdown of the inverter and stuff. So that was the leading theory. So I got my data logger out. I haven't actually looked at the data yet from the data logger, but it obviously wasn't that, right? And then it turned out
before you get to the conclusion here, because I think it's important.
Yeah,
I actually had a conversation with my wife about this recently. So how rigorous were you in your measurements, right? So I saw you took a video and you had that.
I took time-lapse video. Yes, I took time-lapse video. I went and installed my GoPro up there to see that there wasn't any shading or anything like that. Yep.
Well, you said you also had data logging and you...
doing mains data logging as well. Yep.
Did you keep like a journal of like as you were trying these things, or was it kind of more ad hoc? And
this just happened over a day or two. This only happened over a couple of days. This wasn't months or anything. No.
Got it. Okay. Proceed, please. I'd like to come back to that, but the rigorousness, but proceed, please.
No, it's it's something. So anyway, I set up a time-lapse camera on top because the first thing I thought was that, it's shading because, it's on a poor angle and there's there's lots of big trees around and stuff like that. So maybe
and it's just coming into springtime there, right? So it's like the sun is getting higher in the sky and you'll have
it's getting higher in the sky and stuff like that. And but the other thing I noticed is that by analyzing the data is that it seemed to happen about the same time every day, about 9:45 a.m. It started to happen. That's why I thought, shading, the sun's coming behind a tree that's in the neighbor's yard or something. And I don't know unless I'm up there, right, at that exact time. So I set up a time-lapse camera and didn't really show anything, right? It was a perfect day and a time-lapse camera didn't really show any problems. So I thought, it's not the shading. Yeah. Wah, 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 wah.
Right.
It's the shading, folks.
Yeah.
It turns out that I've got a TV antenna up there, right? Which, once again, the shadow of the mast on this big TV antenna, it's right next to and yes, it is between...
Tell me, Grampy Dave, what's a TV antenna?
A TV antenna. It picks up this newfangled digital signal that's... when I was a boy.
You see, kids, when you want to watch Netflix, but it's always on.
Right. Well, the internet.
And then in the middle, there's these things between the in the middle of the program, these things called commercials come on.
And TV's filled with those. Anyway.
Right.
But I knew that the shadow of the mast didn't come over until like 12 o'clock or something like that. So I thought it couldn't be that. And I didn't see it on the time lapse. Right? Although I'm going to have to view it in high def. It might, with hindsight now, I might be able to see it. But anyway, it didn't correlate with the time. Right? It was like 9:45 every day. Boom. It starts cutting out. Right? Which made sense for the voltage being an issue, right? As the sun's coming up, like everyone on my street has solar right now. I don't think there's a single house on my street that does not have solar.
Right. So you're saying the grid starts to get packed.
Yeah, the voltage starts to get boosted on the grid. And I was already high. I was already borderline, right? I knew I was at already like 248 volts, right? And the maximum grid voltage is 253. Right.
Oh, interesting. Okay.
And I knew it did actually get to like the inverter has a voltage display on it and it says like 251 at times, So I thought, it's pretty darn close. So the lead-in theory on the interwebs was that, it was the voltage getting too high and the inverter's being tripped out, and they don't give you that information in the inverter data sheet or whatever. So anyway, it's the shading. But how it worked is of course, the antenna mast has to have guy wires, right? It's got to have these very thin
Yeah.
steel cable guy wires. And there's a
That's
coax,
enough,
of
huh?
course, running up one of them as well, right? There's a
Right.
coax
Yeah.
cable. But I thought that's too far away, right? This giant sun up there, right? You've got this giant light source up there, and you've got this little
Yeah, but
pissant
it's
coax like 5 meters away from it. Surely that's not going to cast a sharp enough shadow.
sun's more like a point source, though. Like that's
Yeah, it is, but compared with the distance away of the coax, like
mm,
and sure enough, the shadow of the coax is this like just this fuzzy little thing you can barely see. But that
yeah.
was enough to drop the output by like 20%
Wow,
of my entire system.
that's
Just
crazy.
this tiny little slither of a fuzzy coax cable coming over the panels, shaded thing. It wasn't a sharp shadow. It was just this fuzzy little thing. And yeah, it dropped at 20%. And that was it. That was it.
Huh.
So after all that, it was the simplest solution. It was simply that that was the first thing I thought of. Oh, my antenna's shaded. And then I thought, nah, it can't be. It's too far away. It's, the mast doesn't come over. I know the shadow on the mast doesn't hit it until 12 or something like that. And surely that's not going to drop it by
Yeah.
20%.
Right.
You
That's
know,
crazy.
it's like, yeah, but there you go. So a tiny little imperfection in the insulation coming on just one panel was
Yeah.
enough to take out my entire string by about 15-20%. Remarkable.
I had a scenario the other day where I forget who it was, but I was like guiding someone along, and I was like, oh, you really want to like, it was like they were setting up like some new system, and they had a sensor in there. And I was like, oh, you really want to like validate the sensor and like make sure you really understand what it's doing and the output and the inputs of the sensor, and just make sure you understand it as an isolated thing. I was probably like echoing when Philip Johnston was on the show, because he was talking about it, and then I was thinking like, I don't do that. Like,
Right. No,
that is some BS advice I just gave. Like,
do as I say, not as I do. Yeah.
That's right. Yeah, exactly. Yeah. And so it must have been someone younger, because that's like the kind of thing.
Right.
That
Yeah. You're going into
But-
grandpa mode. Yeah. Now that you're a
right.
daddy, you're going
Yeah,
into
exactly. Well, and
Yeah.
so that's what I was going to come back to as well. So like this is the conversation I was having with my wife the other day about teaching our daughter, and just like things that I hope that she'll learn. And one of the things was like creativity and resilience was like one of these things that we were kind of talking through.
Yep.
And just like I forget the path of the conversation, but I know at some point I brought up Ben Krasnow and the video where he did the laser etching of traces onto plastic. Do you remember that video?
I think so. Yeah.
Yeah. So he was basically trying to replicate the demo, which actually was the company that Andreas Spiess helps found. The Swiss accent guy from YouTube has also been on the show, so we'll link all of them then. But basically, it's like you go to like trade shows and they put traces directly onto plastic, and Ben did this experiment.
Yep.
And so I've definitely mentioned on the show here before, I think when Ben came back on, but like when he's like, well, on trial 66, on experiment 66, I started to finally get some
useful
traction
data or something. Yeah.
And then it was like, but it was actually experiment 83 where I finally got it to work perfectly. And it's like, that is what I would like to impart to my daughter. I think what I was talking about was like wanting to have some kind of like human biological way to like to be rewarded for not knowing. I think this also came up because there was a post where someone was talking about like they had a friend, they were in grad school, the friend dropped out, went to another career because they said they didn't like not knowing. And then they talked about like how that's all of grad school. And you could say about engineering, science, really just anything where you're trying to make new discoveries. And it sucks. That is a terrible, terrible feeling. But the people that are really good at it, Ben being one of them, other, obviously other researchers, people that are just very resilient in that way. Like you have to be able to sit in that discomfort and like keep trying new things. Like all of the troubleshooting stories that we tell on here, obviously people have heard all of our troubleshooting stories, save the one you just told, I think at this point. But like that, like troubleshooting stories are stories of resilience. And I think that, there's a balance between like, ramming your head into a wall until you break through. There is that kind of resilience. And sometimes that works. Sometimes you're just going to crack your head. But the rigor and like, that's why I asked about rigor as well.
Yeah, right.
One thing that I've in my younger self would just keep trying new things. And that's kind of the banging your head against the wall without actually doing anything. I think once you start to take notes and you start to be more rigorous about it, like Ben in that example, or other, like just scientific method in general, like that, it's like once you get into that mode, I just feel like you kind of level up as a scientist, as an engineer, like just as a troubleshooter. And like, that's something I still struggle with. That's something I still want to get better at. But the people who are really good at it, it is so impressive.
Motivation plays a role as well. Like you talked about researchers and stuff like that. Like if you're doing your PhD, right, you've got to persist because you don't want to piss away your 3 years you've been working on this PhD, right? You don't just want to quit.
It is the sunk cost.
But if you're a Ben Krasnow and you're just doing this as a hobby thing on the side, that takes a different kind of person just to do that as a hobby, for example. There's a big difference between A, you're being paid to do this, or B, you've got some sort of, reason because you have to finish your university degree or your PhD or whatnot, right? And just no, you have no reason to do this, right? But you're going to do it anyway because you just love the challenge. You can't really, I think you'd have a hard time trying to teach somebody that.
Well, and that's what we started talking about too, right? So my wife and I were like, well, how do you actually teach? Like it's not really something, you can't teach it, but you can encourage it, right?
You can encourage it, but whether or not they take it up, that's probably dependent upon their own personality and whatnot. And there's tons of other factors. There's a million other factors. Sure.
Nature versus nurture type of stuff. But like one thing that my wife talked about was like her upbringing, and her mother like inspired confidence in them, and just, really supported them. I think feeling supported, feeling like you have the ability to fail, super important, right? I think having low stakes, but also, like personally, when I'm in like super high stakes, if I'm like, I start to get into thrash mode. That's what I've talked about on the show before. I start thrashing. I'm just like, oh, I got to try this. I got to try this. I got to try this. Where almost always the right way to do it is to like slow down and like analyze things,
analyze the data, and say, go for the most likely scenarios.
What really happened here, right? What is the most likely thing? Like start to make a list and order things out. And it's just like, man, that is so hard when you're just stressed and like,
no, because engineers are usually under time pressure, and that's what we do. Thrash mode is our bread and butter, right?
Totally. Well, and I think and most problems, right? So like, most problems are not, there might be something you're missing that, like something example you gave, right? It's like a small thing, but like something that's, up on your roof. It's not like it's super easy to get to, right? But like it was a non-obvious thing, right?
Yeah.
And if it was something more complex though, right? Then you might keep trying simple things, but you'd have to then increase in complexity. And it's just like, again, it's just like that rigor that's really hard to impart. I would love to hear from people if they know ways to like, either they've made themselves better or they help teach others. Like that is something that we could all benefit from. So.
And also because I was doing this in real time on Twitter, essentially, I couldn't devote all my time to it because either A, I was here at the lab, or B, even when I was home, the kids were doing the home schooling thing, and they had other stuff. I had to monitor them, right? So I literally couldn't go up on the roof because I was
hey, kids, you're doing your homework on the roof now,
right?
It's a beautiful day.
Well, actually, that did happen. I actually went up there on the roof. I said, I'm going up on the roof for 5 minutes. Call me if you need anything. Mom. And it turns out that, of course, he needed me, and he shouted out to me, and I didn't hear him. And oh God, it was like, and I felt really bad because I spent 5 minutes on the roof.
That's what he's gonna be taught, sitting on the therapist couch someday, and then my dad was on the roof.
So, and that would be the opportunity you have to investigate that path. I mean, some things are just easier to investigate, even though you might not think, they're not. That doesn't stand much of a chance, but it's easy to do, so I'll do it. Right. And then you'll do a bunch of those when you should have actually, looked at, okay, which is the most likely, and thoroughly and went to the effort to investigate that one first.
Right. And it's like this upfront investment that you do. So like rigor is an upfront investment, like writing down your hypothesis and like, okay, I'm going to try this thing now. And then how did it work out? Yes or no? And like, that is an investment that like, it does not, if it is always these simple things, it's not going to pay off most of the time. You're going to spend more time than you would if you just kind of like guessed at it, got it pretty right, whatever. Same thing with like setting up experiments, setting up whatever. Yeah.
Well, the solar thing was a classic, right? It was easier for me to set up a timer. Like I thought, oh yeah, shading. I'll definitely check that, right? That is the most likely thing, right? So I set up a time lapse camera and I put it up there, and because that was easy, because then I could set up in the morning, go to work, come back, and it's right, and it's done. Whereas and it didn't show anything, so I wasn't. I didn't rigorously go, well, what if there's a little bit of shadow that I'm not seeing? I needed to be up there right at 9:45 a.m. when it started happening, right? Yeah. And then only when I had time to actually do that, like a day or two later, that I type, right, I'm going to be up there at 9:45 a.m. and I'm going to watch. And sure enough, the coax cable shadow just barely comes, you can barely see it. Bingo, that's got to be it. I wasn't thorough enough.
I think another thing that's in there is like consistency of setup, right? So that's like another thing that really is helpful, right? So in your case, that was a really good move, I think, to like put a camera up there that's like a consistent setup. You get to monitor over time.
But that only got gross shadows. It didn't have the resolution required to see the detail that actually mattered.
Right.
But I didn't know that at the time. I thought,
Right. See, but you could call that automation. You could call that like, you could call that monitoring systems, that sort of thing. Like if it's a less manual process, I think that just kind of, again, that was another investment where you took the time to set it up instead of like sitting there and burning all that other time
it's
later.
One of those things. I was bound to come a gutser, and it was, Yeah.
I think there's the consistency of setup thing though, too, is like another one for me that like I struggled with in the past, because I would, so when I was working at the co-working space in Chicago, I had this set up, I try this thing, I get to the end of the day, I'm like, ugh, tear it all down. And then now I'm starting all afresh, and there might be new errors that are in there. So like, this is where I feel very lucky, very privileged to have like a workshop now, but like that can change a lot of things too. I think.
Oh yeah, well, we've talked about that many times, where a dedicated
consistency,
parts on your bench. I talked about this in the mailbag video I released yesterday. I was going through XDev's, who's on the EV blog forum. I went through his bench, right?
Well, that's the last week we talked about the Nanovolt.
Yeah, same guy. Yeah. Anyway, I'm going to release it as a second channel video as well, just a tour of his lab. And everything's compartmentalized, right? He's got these different stations for different things. He's got ones just for burning, long-term temperature testing. It's set up. There's his thermal chamber. There's all his long-term stuff where he logs everything and does everything. Then he's got his repair station. Then he's got his, other hacking station. Then he's got his test standards station, and it's all nicely set out. So he's got that dedicated space where, he doesn't have to cobble something together for long-term testing. It's all there and it's permanently set up.
That's right.
Right. So he can just put it in, go, leave it for 3 months, and he's got his results. Right. So, whereas me, if I have to do this shit, I've got to cobble something together. It's like, Right.
Yep. Well, that brings me to to another link on our subreddit. Jay Carlson did a tour of his lab, past guest Jay Carlson. And Jay is someone that I was talking to when I was asking about Twitter about workshops and stuff. Jay uses the tray method.
Right.
And this is a couple other people have done this. I think Lewis was another person on Twitter.
Is this the project tray method you're talking about?
That's right. Yeah. So instead of a project box, it's a tray, and basically you just pull it out, work on top of it, and you're done. And that's awesome. Yeah, I mean, I remember you've done boxes.
I have physical boxes, yes, because trays are, you've got to have quite, because my tray in quote marks or my box, that includes all the parts as well. So a tray is not the best kind of, if it's just a board and a couple of other bits and bobs, then you can put in a tray, but
Yeah, I think it's different if it's like an assembly versus a troubleshooting. I think tray for troubleshooting, box for assembly.
And it's got, and by talking about that, like it would have like, you might have like a little debug programmer hooked up to it or something. You leave it hooked up, that sits in the tray. And it goes away with the tray, and then all the connections are all hooked up, right? You don't have to dick around with trying to find the connections and get them wrong, right?
That's somewhere where I've had lack of consistency in the past.
Why is this not working? It's because I've put the bloody header cables on the wrong way. I've swapped a pin, and you spend half a day bloody troubleshooting that, thinking it's your project that's failed when it's actually no, dumbass.
That's right.
Dave has just swapped the transmit and receive on the bloody debug header or something,
Right.
It's like,
Right.
oh God. Yep.
Yep. Yep. I know that one. Yeah. And I think the other problem too is like where there is
Yeah.
code involved. I've been trying to get better at this too, but when there's code involved, I almost always default to the being
Yeah, of
my
course.
fault.
Of
I
course
did
you do.
something
Yeah.
stupid.
No.
Whereas the reality is it's like it's some externality that's like, like why would the code won't just change? I mean, bit rot's something we laugh about, but like it's not something that actually
right.
happens. Like bits don't just flip.
Rare
except for,
occasions when you
cosmic ray type
it
bits.
is incredibly it's so rare you could rule it out, like
Yeah, exactly. Yeah.
Yeah,
If you get there,
exactly.
you've won the lottery, basically.
Yep.
Yeah. Yeah. And so then I start, like you said, I just start to tear things down, and then it's hard to get back to where I was unless I've been very diligent about revision control and everything like that. So yeah, it's good to take a deep breath when that, like, I think one thing is like recognizing the feeling. Like I feel like that manic feeling of like, oh, I gotta try this and try this and try this. Just be like,
yep. And you waste so much time and you get in such a state, you work yourself up into a, yep.
Yeah, exactly. Yeah, and then, take a walk. That's a great one.
Yep.
Just step away, come back, whatever.
Oh boy.
Drink of waters. All useful things. Water glass is a great troubleshooting tool. Rubber ducky is a great water shooting tool or troubleshooting tool.
Speaking of shop tours, Adam Savage on Tested just posted a tour of Grant Imahara's shop. Rip Grant Imahara.
Yep.
Yes, one of us.
Yeah.
Oh, was it a
year? Actually, okay. I just saw a thing about that.
Oh, see, I thought it probably would have been longer than that, but then again, everything seems long during COVID.
No, maybe I saw maybe I saw a thing that was like a remembrance video.
Right.
It was 11 months ago. It's possible maybe it was. Yeah, but
it's very he meticulously designed it from the ground up. It was it's very compartmentalized. It's set up so it's optimized for efficiency and stuff. It really is quite nice. So, yep. It's he's got like big CNC machines and stuff like that. It's very cool. So, and it's still exactly the same a year later. They haven't actually touched it. So yeah,
you kind of wonder about. I mean, like when all that stuff kind of goes away. Like your family would do that sort of. I don't know.
All my stuff is just like
it'll talk about, but
they'll sell it for a song on eBay or something. Or give it away. I don't know. Yep. I don't care. I'm not really fussed over what happens when I'm dead to my stuff when I'm dead, really. Yep.
Right.
I do know, my kids will get
there was something else about Jay's workshop tour that I wanted to, I forget what it was though. Like he does a really nice work down of the whole thing. Obviously Jay's in Nebraska, lots of room there. But I mean, it's just, Jay always writes great articles about embedded and everything else anyway. So it's the same kind of thing, but I cannot remember what it was at this point.
Anyway, it's easy to look organized when you have space.
Yeah, I agree with that.
Yeah, it's so easy. Like I would love to have like instead of a tray per project, I would love to have a bench per project.
Yeah.
Like seriously, like if I was super rich and I had like, 500 square meter space, like I had an entire top floor of a commercial office building just to myself, I would literally have a separate bench for each project. And there the project would sit on the bench with the required test equipment because I've got so many bloody scopes and meters and stuff, it wouldn't matter. Yeah, and everything would just sit on that bench. And that would be the project bench. So I could just walk up to the project bench and spend an hour on it, That'd be... Yep. Which is a very inefficient way to do engineering, by the way, is to just spend an hour here, hour there. It doesn't work because it takes you an hour just to get up to speed,
There are startup costs.
But anyway, that'd be cool, totally. Right? I'd love just to be able to walk up and tinker on, a thing. But now I've got to put it away. And then once you put it away, it's gone, right? It's like,
Yeah, I've been actually feeling that on the 3D printing space. I've been printing out some cases. I've been posting about some of my progress of just like, so I've been doing these off-the-shelf modules. I just got like some cheapo, like external MOSFET modules, and then like breakout boards and all these other things. And I'm basically kind of like, almost kind of like how a PLC wiring cabinet is. I'm kind of like replicating that,
right?
But it's just like wires. So just like point-to-point wiring for modules and stuff like that instead of doing a board. But I've been trying embedded. I succeeded in embedding M2.5 and M3 nuts into the print. And so that I had captive machine screw threads. And an exciting experience, but not ultimately something I think I'm going to do that often.
Yeah, but don't you just make it the thing to a certain size and then just shove them in? Are these the press fit ones?
These are not the press fit ones. So I had some press
Oh,
fit ones, but of the
okay.
wrong sizes. And so in the meantime, I was like, oh, I could.
Right, okay,
Yeah.
because they are the best
Yeah.
solution.
Well, I think the other thing too is that I was remembering putting together an old 3D printer, and like, you know, like there are certain formats where you can like slide in like a nut, and that works great. You know, basically the slot's already there. You slide, you know, you basically drop it in. You drop in a nut, and then you're able to screw in like kind of like horizontally to it. But the thing that my
Right.
brain didn't realize is that that's because of how it's printed, right? It's printed with like an opening at the top, and then it basically becomes like a little
Mhm.
plinko thing you just drop the nut into. In this case, I'm actually trying to do it horizontally. So I actually like built up these supports, paused the print, inserted a nut, and then tried printing over top of
Yeah,
it.
yeah.
And that
Yeah,
is
right.
not the way to
Yeah,
do
no.
it.
No, you don't wanna be doing that.
Yeah.
No, no. The, fluted press fit
Yeah, exactly.
ones
Yeah,
are
and that's what
the
I
bomb.
landed on
Yep,
as well. Like, yeah, like the heat
yep.
set M3 press fit things, like very easy. You can even get like a Weller tip that's basically just like a brass. It's just like a
Right.
piece of brass basically. It's been machined, and you just like use that and heat it up, and goes right in, and no big deal. But you know, just hold downs and cases and all that other crap that comes along with assembling larger things.
I kinda miss the days when everything was in 19-inch racks,
Yeah,
you
yeah.
know?
I mean, that's
Yeah.
I think starting
Yeah, I
from
come
a
from a
large
19-inch
space
rack
is
world,
definitely
you know?
a nice start. As
Yep.
you get more and more complex, it's definitely. I
Mm.
think it's good to start from the big side of things too, and then kind of shrink down later. That's another
Yep.
lesson I keep forgetting. I'm like, oh,
Probably like 2/3 of the production test equipment that I've designed over the decades,
mm-hmm,
it has been rack mount,
mm,
you know? It's been
okay,
19-inch rack mount
yeah,
stuff, you know?
yeah, that's nice. Yeah, and then it's
Yeah,
lots of
because
space and
it's nice to have the luxury of, you know, just, like, not having to think about the case. It's like, "Oh, of course it goes in a 9-inch
yeah,
rack because we
right,
have all the test instruments in there. We have the 9-inch rack mount
right,
PC to
right.
control it, and we
Where
have,
else would it
you
go?
know, like
There's no
yeah,
space on the bench,
and all the
obviously.
wiring's at the back. Like, there's no connectors on the front unless you absolutely need it for some, you know, use a plug-in
Mm-hmm.
test reason or
Yeah,
something,
yeah,
but generally, yep, it's all of your decisions made for
yeah,
you. 9-inch rack, all the connectors on the
yeah,
back. You know,
yeah.
it's
Nice
like,
and easy.
okay,
Yeah.
you know, it's really
Yeah,
simple.
yeah,
Yep.
that's the way to do it.
Yeah, it's good.
I think just having like the kind of like the mental model around like a mechanical assembly is good to have these days. You know,
Mm.
as things keep getting smaller and like I don't know, I don't print anything that's pretty. That's for sure. It's all still
Right.
like black square rectangle. You know.
I've done videos on this, and I'm sure we've mentioned on the Ampere over the years, is that often a good way to design a project is to start with the case.
Yes, we
Like,
did because
choose a case
you
that
made
you
fun of me
like.
on one of your
For
videos without mentioning me.
did I?
Yeah.
Right. Did I?
Yeah, because
Really?
I was asking on here. I asked you on it, took a chance, asked you on air for some
Yep.
help sourcing a case, and then you know you look at the camera like, oh, someone couldn't figure out there's battery holders or something like that in one of your videos for you,
Right.
Dave.
Yes, you can buy cases with battery
Yes, I know
holders
that now.
and then design your project around the
Yeah, totally.
case.
I think that's right.
That's,
Yeah,
that's a real, it's obviously not for
yeah.
everything.
I think at
But if you
least
don't know, like if you've got the idea for a
yeah.
project, like okay, it does this thing and it's got to have some sort of usery form factor
Hmm.
kind of stuff, but you're not, oh, I don't know, what does a case look like? Then just
Yeah.
browse the
Start from one.
catalogs
Yeah,
until you
yeah, yeah.
find someone that looks good. If you need batteries, go search cases that have if you need a 9-volt battery, go and search for ones that have a 9-volt battery snap
Hmm.
holder built into
Yep.
them,
Yep.
and then work from there. And it's great because once you have the physical thing in your hand, you go, oh, all the dials and switches in your brain light up,
Hmm.
and you go, oh
Yeah.
yeah,
Yeah.
okay,
Yeah.
and yeah, it's great. Works
Yeah.
wonders.
I
Yep.
have actually to
Mm.
take it back to I just remembered from one of the projects that I have that's in a nice case. I had a troubleshooting story this week, and it ended up Occam's razor, same kind of thing, where like
Mm.
I had like multiple selectable like feedback resistors as like a boost converter, and it was like 5, 12,
Yep.
24 volt output, and so like basically the dividers had things coming back, and I'm like, man, this thing is just not out is just like outputting, it was like 3.5 volts input, and then like 3.3 volts output. And I was like, oh, am I, maybe I'm configuring this wrong, and whatever. Yep, nope, hadn't turned on the enable pin. Just one of
the. Yeah, well
classic.
Yeah. Yep. Or you leave it floating.
Yeah, that's a classic.
Yes, because you forgot to solder you missed that solder joint, and it's just making intermittent contact and floating. Oh goodness, Yep.
It's just
that'll ruin your day.
High quality troubleshooting stories right there.
Oh yeah. Oh boy.
Yeah. A lot of fun.
Love it.
Yeah.
All right, what else we got on the list that we didn't cover last week? Because we didn't know we'd do it this week.
That's right.
This show.
What else is on the list? I had sorted by top. Just Intel lying.
Lying?
Well, okay, there's been all this to do about like, the US is pulling chip design back from overseas and blah, blah, blah. Who's going to do it? Oh, Intel's going to do it. And then there's this article on fortune.com, which, starting from a bad place. But it's basically like, what the link is, car makers need to get out of the semiconductor stone age. And they're like, basically, we don't make anything bigger than 16 nanometers. And it's like, well, of course you don't. Like, you're Intel. Like, but why would you? But, nothing is, there's actual like analog reasons to not have, yes, you can operate at these lower. So if people want to go and listen, when Adrian Tang was on the show, he talked about like there is possible. So Adrian was the JPL chip designer. He's like, yes, it is possible to do this sort of stuff. Most of the reason it's not done is because the package is not there. Like it's not available. Like you can't get access to the analog design package for the lower stuff. But also there's like tons and tons of leakage at 16 nanometers that like, you have to do all this crazy shit there. And like if you're trying to make like a trench FET, you're not going to use 16 nanometers to do it. Like you want millimeters effectively, not really, but
right,
like
millimeters. Damn it. Yeah.
I mean, like it's just like it just is a really, I don't know, tone deaf kind of thing. Like the chief executive of Intel says, I'll make as many Intel 16 nanometer chips as they want. It's like, okay, cool.
But that's not what the car makers want, because, the average car, does the average car have anything that requires?
I think vision type chips these days,
vision chips.
Probably infotainment, one of our favorite words here on the Amp Hour.
Infotainment. But for most of the other stuff that's just running and controlling the car and sensories and stuff like that.
They need to do load dump testing, and they need to do they need to buck things down. You need to operate off, like you're operating off a 12-volt rail, and it needs to be able to survive a load dump. It's like, okay, cool. Like, can you do that, Intel?
Well, doesn't the average car have like over 100 microcontrollers in it?
There are,
and I'm not talking microprocessors. I'm talking little microcontrollers that don't need to be 16 nanometers.
Yes, there are. Right? There are a lot. Apparently that number is shrinking. They're starting to consolidate. Some cars are starting to, like the Teslas of the world, are starting to consolidate more, pull stuff more back into the centralized.
One central processing thing.
I'd say
what, wireless.
Like, what? No. Like one or two. Like basically having stuff kind of more centralized.
Right.
So well, I'm sure people will get mad at me for talking about this stuff.
Sensors transmitting data directly back rather than
that sort of thing. So we don't know anything about cars here.
Local processing.
Other than,
no, of course not.
There's a lot of other stuff in a car than the vision type chips that Intel wants to make. So it's like, I don't know. This is where I just always kind of like bristle at the idea of like, oh, Intel's going to do it. It's like, man, Intel couldn't even make like a, little shitty makery chip for more than 6 months before someone killed it. It's like this is not the business they want. They're used to like high margin. Like, okay, maybe they're they're moving into the foundry business. Maybe they'll figure it out. But like if you've moved up through the ranks and you've built your career based on like these business ideas that have built Intel to what it is, and it's done very well, then like when someone comes and says, oh, we want to pay 10 cents for a regulator module, no, no, we don't want to do that.
But I don't know why they can't be in every market, right? Why they can't cater, like even spin off part, or
I think it probably comes down to like, again, this is conjecture. I don't know the economics of fabs or anything like that, but like I would imagine that like the there's probably some baseline of like how how many wafers and like basically like the cost per square foot in a Intel fab,
right.
because they are leading edge,
Yep.
right? And I think
Of
actually,
course.
to their credit in this article, I think they talk about they're not going to move old equipment back in. Like that makes sense,
Right.
but
Okay. Yep.
something's got to be done there. So it's like, do you go and invest? This is kind of, I think we talked about this a couple shows
Well,
ago,
why do Intel have to do it?
because it's expensive, and they're a big
No,
name, and like there
yeah,
is
okay.
there's a lot of expertise there. Like, so like, yeah, there are other people that could do it, but it's like, are they going to be able to spin up fast enough? Are they going to be able to like lobby
Right.
governmental type?
Yep.
This is a lot of government stuff too, and it's just like,
Oh yeah, of course.
So
Yep.
it is an interesting time. Yeah, I don't know.
Well, how about the chip fab at the National Security Agency? Why don't they start churning out voltage regs?
Yeah, maybe.
Yeah.
I don't know. I think
for those who don't know, they have their own in-house chip
Totally.
fab because they don't want the IP to go out
Yeah.
anywhere else. They don't want it to leave the wall. So, yep.
Yep.
I don't know the details of it though. I don't know. I'm sure it's out there. Maybe.
Dave
You can
has
find
been removed
details
from
if
this
you want.
podcast. Yeah.
Oh boy.
Yeah.
Yep.
It's like it's big stuff, right? This is all big money, big business, like government involvement, like
Yep.
and even without government involvement, just like automaker stuff. Like automakers are just monstrous. Like you just, like at the scale they're talking about, it's really tough. And so I think, one of my predictions is, okay, Intel may be getting into the foundry business, but I think there is going to be more market for global foundries or even like the Skywaters of the world to expand more. I think they will see more business, but actually not from traditional chip companies because they're all buying each other anyways. I think car companies are going to be like, well, I guess we got to make our own chips. We got to I think there is that know-how out there. Apple's going vertical, like all these other companies are going, not all these other companies. Tesla's vertical, right? They have their crazy ass like M1 or
but Apple don't have their own fabs, do they?
No, they don't. I don't think that's going to change.
Right.
But I think, Intel is moving in the foundry business. I think other foundries that are out there, I think they will continue to, do well, grow at a higher rate than they might have otherwise. But I think it'll be because some of the chip knowledge will move in-house. What I'd love to see is if there was that, if it drove more adoption of open tools. I don't actually think that's going to be as much of a large scale thing, but that would be super cool if it was. If like, if a Ford is like, well, we got to design a chip module, and do we want to pay Mentor Graphics for like a full license or whatever? Yeah, if they probably will, right? It's it's a drop in the bucket compared to otherwise.
Of course, you're getting down into the details.
Yeah. But what I'm saying is, I would love if like a Ford was like, well, if we have to build a new chip company or a new chip division, why don't we do it with these open tools that are out there? I don't think that's going to happen because the people they hire are probably also used to using the Mentor Graphics of the world. And
correct.
Whatever, so
yeah.
But a guy can dream, Dave. That's
right.
I think it's just this is an open.
Yes.
This is just big money, big tech stuff that's way above our pay grade.
Indeed. Yeah. How many companies in the US, we'll take the US as the example, can actually produce
their own?
The bread and butter chips.
Like in their own fabs?
Yes. Fabs in the US is what I'm talking about.
I think Microchip can still do it. I think TI still has some limited, but I think they're, they got burned because they moved a lot of stuff out to TSMC as well.
Mm-hmm.
Who else is out there? I mean, AMD is at Global Foundry, so like, but they're not like they're all over. I mean, like all these companies are like multinational anyways. So.
Oh yeah, exactly. It makes it hard.
Yeah.
But,
the chip, the places that I know the chips are made in the U.S. is Intel's up in Portland, Microchip's down in Arizona.
Mm-hmm.
Intel's also down in Arizona. TI, I think, still runs a fab in Richardson, Texas. There's a bunch of stuff in.
Here we go.
East
there
Fishkill,
is a wiki, of course. List of semiconductor fabrication plants, and you can search. You can sort by country.
Oh, cool.
This is good.
Yeah, that's great. Can you link that to me, please?
So, there's 2 in Australia. Yes, I will.
Oh, interesting. Are they? I bet they're at universities. That's the thing too. Like, it's also about scale, right? So, like having the ability to make one wafer is a lot different than being able to like.
Oh yeah, no.
Crank wafers
to make,
out, right?
Make production.
It's just. It is.
But at this point, the automotive manufacturers, for example, they would probably pay anything if they could just get the chips. They would happily, pay 10 times the price.
Oh,
or
10
whatever.
Oh, maybe.
You know.
I don't know.
Well, if it means the difference between shipping a car and not shipping a car and actually making a sale, I think they would.
I don't know.
Yeah. Germany's got a lot.
Germany's
got a few. Oh, Japan's got a lot.
Those recalls are pretty expensive there, Dave, as you may recall. Yeah.
Interestingly, Japan's probably got as many as China or more. Actually, Japan probably have the most fabs.
Oh, interesting.
Of any country.
Yeah, I mean, they still have a lot of they were still very big into Rome. That's interesting.
Taiwan.
I was thinking like memory
Taiwan,
and drivers and stuff like that. So
right.
Sharp, Fujitsu,
UK's got quite a few. US actually have a lot. Wow. Actually, I could almost as many as China.
Oh, interesting.
Wow. Infineon have 2, 4, 6 fabs in the USA. I assume that these are all
Can you sort by country?
Valid.
Oh.
Yeah, I'm sorting by country.
Oh, interesting.
I'm looking at the US.
USA.
Intel have 5 fabs in the US.
Yeah. Yep.
All in Chandler, Arizona.
That's not true. They
NXP.
They have some up in Hillsboro as well.
Okay. Are you saying Wikipedia is not?
No, it's further down. It says right there.
Is it?
D1C, D1B, D1D.
Oh, sorry. Yeah. No, okay. So it didn't sort by. Right.
Yeah. So like Malta, New York, Ithaca, New York, Albany, New York. That's all. I kind of just put that all in like the East Fishkill. Like that's like Global Foundries. IBM was there. Like Global Foundries spun off from AMD, I believe. Cree is in Durham. So that's right near me. That's. I mean, Skywater's the one we've talked about before. They're up in Minnesota. That's north, kind of up by DigiKey. Yeah, and so I think it's really. Do they have capacity on here too, or no? No, they have processing nodes.
No.
So on the right side, on the far right, they have.
It's saying that Apple actually do have a fab, but I don't know what its capabilities are.
Do they say it's in Texas?
Yeah, no, San Jose.
Oh, interesting.
Apple, formerly Maxim.
Okay.
And then formerly Samsung, so it's an old.
Got it. Yeah, they did a lot of.
It only goes down to 90 nanometers.
So after I was at Samsung, which was down in Austin, they had moved up into the LSI business. So like large system integration. I don't know what LSI stands for, but like they did a bunch of Apple stuff there, basically.
Right.
But Apple, Apple is I think a lot of people are going to emulate Apple, especially given so you're looking at the marketplace right now. You're like, well, we can't get any chips for 5 years. What are we going to do? Again, I hope it turns into...
Yeah, but Apple aren't making them, though. That's the thing.
I think you're right about that. Yeah, but I think...
Apple they're designing their own, but they're not making them. So it's
Yeah, true.
It's not necessarily a thing I'd follow.
Yeah, but if you're like sitting around, if you're waiting around versus like being able to do something and source it from a foundry, if you can get time at a foundry, I guess. I don't know. I think this is a good example of like maintaining infrastructure. I was not a fan, as people remember, when Analog Devices talked about outsourcing a lot of their stuff to TSMC. They even said the process technology, we're just going to do what they do. And it's like, that's just, it's a very, I think it's a very
your companies, I'm not going to say
short-sighted kind of thing. It's just like, it looks better operationally. Yeah, your operational budgets are lower. It's like, expensive as hell to do that, but that is your moat. That is like how you are maintaining your dominance if you have it. And I don't know.
No, that was it's dumb.
I'm not going to be a semiconductor executive anytime soon, so that part's not a big deal.
Exactly. Maybe we should get one on the show.
Sure.
Maybe we should attempt to get a fab CEO on the
CEO. Yeah, I think that would be boring.
Yeah, well, no, if they're an engineer, we talk about and we can do so we mainly talk about the engineering, and then we have a side discussion on the politics of it all.
Oh, sure. Yeah, I'm sure they'd be. Yeah, CEOs are known for showing their hand.
Oh, yeah, right. Yeah, exactly.
Yeah.
Oh boy, fascinating. Yeah. Anyway.
Yeah, we'll link. We'll definitely link this list, and this is a good find. So we'll have to link this in. It's great.
Right. So the easy solution is to just simply make your own chips.
Yeah.
People.
On your desk.
That's just with your chip printer.
Yeah. Great. Killer.
That's coming this year because Chris predicted it like
10
11 years ago or whatever.
That's great.
Yeah.
I'm just saying it would be really useful by now. I'm just saying, Dave.
Yeah, it would, wouldn't it?
It
yeah,
really
yeah.
would.
So would those Mars bases, and
exactly.
yeah,
That's what I'm saying.
yeah. Right. Oh boy.
Yeah. This is another link I put on here: demos over deadlines. This is something my friend's company does, and I really like this idea. And so basically, like this whole article is talking about like, oh, software is so hard to predict in terms of timelines and stuff like that. And there's obviously some things you can't get out of in terms of if you've promised it by a certain date. But I really like the idea of the demo as like a measurable piece. This is tied a lot into like, what's it called? Not lean. What am I saying here? A sprint. It's a sprint is part of not extreme programming. Anyways, my brain's not working.
What are we talking about the demo for? We're talking about a demo for investors, or we're talking about a demo for customers?
Internally. No, for one another. So like instead of your boss being like, you must have this on my desk 3 weeks from today.
Yes.
They say, show me a demo as soon as you can of every piece that you think is relevant. And so, it might be in software, it's a little easier.
Well, that's called a Gantt chart. It's called that's called a milestone on a Gantt chart. Show us this thing where you're okay. It's week 20. You're supposed to be at this point. Show us this thing working.
Sure, could be. Yeah.
It's like that's.
I feel like there's always the focus on the
engineering.
Yeah, I mean, but I feel like the demo is like it depends how big it is, right? So like for hardware, if it's like the board is finished and working, that's a lot different than like, oh, let me show you the data from the ADC and how linear it is, which is like the thing I did this week. And that's kind of like the difference is like you kind of break it down into smaller parts. And I've been at companies that have done that sort of thing, like on the hardware side, but I think it's really hard in hardware to do that sort of thing because if it's just one little piece, like if it's just the LED lighting up, like that doesn't really feel like a lot of accomplishment. And yet if you make that culturally part of a thing, you're like, well, actually
it's the tools work.
Yeah, exactly. The tool chain. I think that, the tool chain.
Pat on the back for everyone. Tool chain works.
Cake in the lounge. Cake in the lounge. I just really like this as it's like a kind of framework for building out teams and like, I don't know. I'm sure you've done this sort of thing in your past work as well though, right?
Of course.
Yeah.
Thing I want to know is, are Gantt charts still a thing?
I think so. Yeah. I mean,
leave it in the comments down below.
Yeah.
Because they were all the rage in the 90s.
Yeah.
Are they still a thing?
Agile. That is what I was trying to think of. I think agile is that's like the new thing, but I think that there's.
Hang on. I'm gonna ask this on Twitter right now.
Oh, no.
I'm gonna set up a poll.
Okay. Oh,
yeah.
This is fun.
Yep.
This is good. Good radio, Dave.
And now I've got to figure out how to spell Gantt.
Is it 2 N's or 2 T's? That gets me every
2's. Yeah, I know.
Every time.
Yeah,
I know there's 2 of something.
Yeah. Yeah, I know. Yep, same here. G-A-N-T-T. Yes, I thought it was double T.
Yeah,
okay.
Yeah, I think it is. I think there are some things that are still pretty linear, right? I mean, I think that's what it really comes down to. But when you start to like try and compress stuff, you need to show something, right? So like, again, if you're building out like a full, my past experience was like, there was a 6-month development cycle. To get to Rev A, it was 6 months on one project that I was on. And it's like, that's really tough because if you get to the 6-month mark and you're like, oh shit, this doesn't work. That's like, it's like your teammates might not know what you're doing. You're going to have like status updates, but like showing it is really important. I think it's getting easier to do that. But like, again, from a cultural perspective, it's tough because I don't know, like everybody working remote too. Like, how do you actually show, it's tough to show like hardware in situ as well. Like, oh, the LED lit up. And well, I could fake that. I specifically know how to fake that.
It's the old smoke and mirrors demo. It's like never give. And well, okay, there's a positive and a negative to giving an engineer a demo deadline, right? One is that they're going to fake it with the smoke and mirrors.
You could,
right, just to shut you up because they know, because the engineer knows where they're at, but they've got this pain in the ass deadline for this stupid demo, and that's not how they want to do things in that order.
I realize you didn't read the article, and that's okay. But the idea is that there isn't a deadline. You just show it when you have a thing.
Yeah, but I'm talking about you do get. I've had these.
Oh,
I've
okay,
had
okay,
these
okay.
deadlines. Like show us a demo. We want a demo next
Got
Friday.
it. Yeah, that's
You know,
rough. That's basically like a
I've
mini
had
delivery,
this,
right?
right?
That's
Yeah, it's a mini
that will
deliverable,
lead to
right?
smoke and mirrors.
And
Yeah.
that is the wank word bingo buzzword, deliverable,
Yes.
right?
Deliverable.
Not to a customer, it's to
Yeah.
me, the
Right. Right.
manager, deliverable,
Right. Right.
please,
I
which is
snap
the
my
demo.
fingers,
And yeah,
servant.
and I will not be above saying like, yeah, I've done smoke and mirrors demos just to shut them up
Yeah.
because I know where I am in the project, and you guys are just wasting my time by making me meet this demo deadline. So you're going to get a freaking smoke and
Sure.
mirrors,
Sure. Sure.
right? And yeah, no, screw that.
Like,
Right?
would you
Whereas other
in that
times
same
it's good that you
same
can,
like scenario though, like the same maybe even the same project,
yeah.
would you offer information otherwise, or was it just like culturally you were like, oh well, I'm not going to show anything because it'll just mean that more is asked of me.
If they come around and they want to see what I'm doing, that's
Yeah.
fine. I'll tell them where I'm up to and stuff like that. But don't judge me. It's like, no,
Yeah.
go
Yeah. Yeah.
away.
I think that's right.
I'm the one who's organizing how to do this entire project. It's just me, right? And you just come in and want some. You're trying to push some schedule that is just I know that's the wrong way because you're not the one doing it. I'm the one doing the project. So that's why I always did, if possible, I always did my own Gantt charts, right? I would not let them push the Gantt charts on me.
Interesting.
Right?
Yeah, turn it around.
Because
I Gantt you. You don't Gantt
because
me. I
I'm
Gantt
the one
you.
who has to do the work. Right? I'm the one with the experience and the one who has to do the job.
I am the one who Gants.
Right? I'm not saying I'm not saying that they're not experienced managers, right? They might be, but they don't know the nitty-gritty detail. Whereas almost off the bat, like, if you're a really experienced engineer, right off the bat, you're going to know, okay, this part's going to take me X amount of time. This part will take me X amount, like, oh, this part's a real hurdle. I've got to allow, a big amount of time for that and, stuff like that. So whereas the manager doesn't necessarily know that. The poor schmuck engineer tasked with the task of getting the job done is the one who should be set in the Gantt chart, in my opinion.
I think that's right. I mean, I think you basically just restated like some of the agile stuff, like like that's like
okay,
that's like a big thing.
And you should have the skills.
Yes,
young engineers out there, like seriously, if you did not get a class, if you did not get a class on project management, not from like no, it's.
I think one of the things is
when you can't even teach it, but you need to know the skills of creating Gantt charts as well.
Yeah.
But you also need the wisdom, you need the knowledge behind it to be able to put reasonable estimates on there. Right.
I think
so.
Dave, if you update your vocabulary slightly, you could move into a whole new paradigm of agile.
Right,
it's not a Gantt chart; it's a burn down chart.
A burn down! I've never heard of a burn down chart.
If you look it up on many agile
burn down.
But that is one of the things that I like. That I do like. So I read about agile. I've been part of teams that have tried it.
So you want to get down to zero because you've got your deliverable on that day, and so you're let me guess, you're either above or below the trend line.
I think there's really no judgment on the trend line. It's more of just like. So like what
you want to bet? If you can be judged, you will be judged, dude.
Yeah, that's true. I think so like in a best case scenario, like when I've read about this stuff, when I've heard friends talking about it, like in a best case scenario, people are giving like real estimates on like how long it takes to do things, and like there's a whole bunch of BS out there. There's Scrum Masters and all the other things that are out there. And this is we are many years behind. This is 20 plus years old.
Yeah, I know. Point. Yeah, we're totally, because like both of us have been out of large corporate business for a long time.
Right. But startups love agile as well. So like I said, there are some things that I really like about it. Like the things that I think one of the most powerful things of it is like if you can't estimate something in a good way, if you say it's going to take 2 weeks and it's like the actual work's going to take 2 weeks, it's like, well, no, you can't. You're not allowed to do that. You got to break it down more. Like that is, as a general rule, like if you were just using that as a guiding principle of like, well, you got to break it down more. You need to have it in like half day chunks at a max. It's like that alone is a guiding decision, especially in hardware, assuming you're not like putting in the timing of like waiting for a board to come back or waiting for a board to be assembled or whatever. Breaking it down more actually makes a lot of sense. I think, like, oh, I got to check the linearity of this ADC. I got to, implement a new 4 to 20 controller. I got to do all this other crap. And it's like, yeah, okay. So then you start to like add it all up, and you're like, and that's effectively what a Gantt chart is too, right? I mean, like you're just breaking it down more and more and more. If you're just saying,
but Gantt charts also
testing is 4 weeks.
show dependencies as well. You cannot proceed beyond this point unless you've got X and X line meet up, right? You know, so yeah. Somebody we've got feedback from Twitter here
already
from my poll that I put up. Shura Lubreski.
Boy, Dave does great with those Eastern European names, huh?
Oh, great. Yeah. Gantt is bullshit. Use PERT charts. Oh, we've got a PERT fanboy. Jonathan Mann says, sadly, yes, I thought full-on Gantt charts full of every subtask are pretty unwieldy. He much prefers the roadmap. Really is a high level Gantt chart.
We're into methodologies and frameworks
planning. And sprints. Oh, sprints is like another wank word bingo.
That's the agile thing.
For planning day-to-day tasks. Okay. Yep. So anyway, 66% of people have said yes, Gantt charts are still a thing.
Yeah, I think hardware is. I think it's hard to remap a linear thing like hardware where it's very defined. It's like you can try and work ahead and whatever, but like until your board's on your desk, there is no effective there's no way to do a 3 mil space trace like high quality circuit board in your lab. I know they keep trying it, and it's just like send that out and it's going to be great.
I've done 6.6.
Yes, but, right. Yeah, there's
it's a bit how you do it.
Yeah, and like the Dragonfly MX or whatever that thing, not MX, but whatever the Dragonfly, like people keep talking about that one. It's like, yes, there's some very high end tools that will have some result that might approximate it, but probably not 12 layers or whatever else you need. So it's just like, okay, so there are some like true just bits versus atoms kind of dependencies, and you can't get around those. And that's when a waterfall chart does start to make sense. Well, no.
I
think it's just it's tough to make this stuff work, right? I mean, there's whole Jack Gansel made a career on like managing software projects or firmware projects, and like like the same thing for hardware projects and software. It's just like there's so much stuff out there.
I think just all you've got to do, give me a date, leave me the fuck alone. If I'm allowed to drop the F-bomb on the ampere.
Not usually.
Not usually, but we're going to make the exception.
Yeah.
That's probably the first time you've heard me drop the,
No, not the first time I've heard you. That's for sure.
Right, okay. Anyway, yeah. Yep.
Yeah.
Give me a deadline, leave me alone.
Yeah, I think it's tough when it's like bigger teams, right? Anything gets hard as you have.
No, of course. So. It of course, it totally depends on the project. But I'm so used to being the only person on the team. It's like, I've worked in larger groups, but I've done a ton of stuff. It's just been me.
Does not play well with others. Does not play well with others.
No. That's why they put me down in the dungeon.
That's right. Yeah.
Yep.
You moved my desk again.
My stapler. My stapler was my red stapler.
I rewatched it recently. It holds up.
Oh yeah, I haven't.
Yeah,
I'm gonna have to do it. Yep. Yeah, of course it does. Of course it does. It's classic. Yes. Those who don't know, tell them.
Office Space. Yeah.
Office Space.
Mike Judge. What a genius.
Yep.
What a genius.
Yep. Fantastic. Is he the one who also did? Oh God, the name's escaping me. Where he goes into the future and everyone's dumb and he's the smartest guy in the world.
Idiocracy, yep.
Idiocracy.
Oh, yeah. I mean,
is that it?
Yes,
it's his.
He did Silicon Valley.
Yep.
I mean, like, yeah, man, he's the prognosticator of prognosticators.
Right.
Yeah.
So he's the Scott Adams of movies, is he? He's like the Dilbert, the Scott Adams of.
He's a little, better than that, but yeah.
Right.
Yeah, man. Yeah.
Well, didn't Elon Musk famously said if it's in a Dilbert cartoon, it's banned here at SpaceX or Tesla. Really? That's what he said.
Interesting.
Yes, if that is a thing in a Dilbert cartoon, we are not doing that here.
Must be tough not being able to drink coffee at SpaceX or Tesla.
Right.
Can you imagine that? If you just banned, so like you have 1,000 engineers on staff, and then on just any random Tuesday,
the coffee machine breaks.
Coffee is verboten. You are not allowed to drink it ever again on campus. How many people quit that day? Give me a percentage.
Well, I can only speak for me.
You'd be
wouldn't,
fine.
'cause
Yeah,
don't drink
I
the
get
shit.
it.
Yeah.
I'd
Yep.
quit that day.
Right.
85, 90%, maybe. Yeah.
Yeah. Right. Oh boy.
Yeah. I don't know.
No, they'd just be down on them outside like smokers.
Yeah,
you know?
right,
They'd
right,
be like, huddling together in the alleyway
Yeah.
outside the building.
Right.
And
Right. Everybody's going off campus just to get their fix.
down on those durries.
Yeah,
you know?
yeah.
Oh boy. Yep.
Well, if any of you listening have a boss that tells you can't drink coffee, let me tell you right now, they're not allowed to do that, and you're gonna be fine.
And if they ask for a demo, just tell them to bugger off.
Yep.
Just waste my time. Go away. Yep. Speaking of which, we should go away because our amp hour's
Our
up.
amp hour is up.
Yep.
All right. Well,
That's it.
hope you don't have to do any demos,
Done.
even though you do them voluntarily every week on your YouTube channel.
Yep.
Demo machine.
Catch you next time.
See ya.